Okay, everyone, let's continue on to Section 4, Multi-Tenancy ACI's Ultimate Weapon, Fabric Tenants. Okay, everyone, so let's start with Section 4. Let's begin by discussing the Fabric Tenants. And in ACI, this is 90% of your workload. You're going to be configuring tenants, you're going to be creating application profiles, attaching endpoint groups, adding bridge domains, and connecting them via a ROV or a VRF. So, why we do tenant? In a traditional network, let me draw real quick. We have a core, we got a distribution side, and we got the access layer, where usually my VLAN routing happens. Core. At the core switch, my VLANs are routing. All my default gateways or SVIs are configured at the core. Well, here's the problem with this architecture. You cannot isolate VLANs in a traditional campus or a three-tier design because the core has all the routing for all those VLANs. And yes, you can do this. Have a separate environment, separate VLANs, and then have some sort of firewall here in between. To do that, yeah, I personally don't like that. When it comes to maintain that environment, it's a pain. I personally don't see this as a feasible approach to segment your network. And we're just talking about a single environment, a single company that will like to have separate tenants or separate networks environment, but running on the same fabric. This is not the case with a campus design. Campus design is just, hey, I have my core, my distribution, my access, everything talks everywhere, done. With ACI, however, I can classify traffic on particular tenants. So let's say we have a couple of web servers, right? We got web servers. With that, we need application servers, we need database servers in order for us to build that web farm. Here's the problem, and this comes from a security standpoint. If we're talking about a single environment, right? If you're going into cloud, host multiple customers environment, then this is definitely the way to go, right? We separate also customers by assigning them different tenants. And anything that is inside this particular tenant will be able to exchange information for production purposes. You can classify policies, you can add policies, objects, you can create contracts, so then communication inside the same tenant happens. Let's say we have a company called Pepsi, right? And we have a company called Coca-Cola, right? We are a cloud hosting provider. We host compute. We host storage, we host numerous services on the cloud in which both Pepsi and Coca-Cola agree to subscribe to us, right? They are all going to be running their applications on the same network that I have. So on my fabric, I'm going to be running applications for both Pepsi and Coca-Cola. Do you think that Pepsi and Coca-Cola will agree to allow traffic to hit both networks? Absolutely not. They want to make sure that anything that relates to Pepsi or anything that relates to Coca-Cola will be separate in its own little domain, quote, in its own little network, because this is what it is. It's a virtual network that we are just running on top of a fabric. The fabric doesn't even care who does this traffic belong to. All it knows is that it has some policies, it has some statements, and it just needs to operate based upon that, right? So let me go ahead and wipe a little bit here. I'm going to clean this up real quick, right? And then we're going to go straight into Fabric Tenant. Okay, so speaking of multi-tenancy, now you understand what the power of tenancy is when it comes to ACI or any other SDN-based network, right? We can virtualize a whole network to be running on top of a physical network, right? So let's create this tenant if it makes it easier for you to understand. Think of it as a network. Tenant is a network. This is network for the web servers. So I just built a completely different network for my web servers. Then I built another network for my Microsoft tenant. Both of them are going to be communicating on the same fabric, right? They are both communicating my same ACI fabric, but this is all happening on top of my physical equipment. Web server farm let's change the color here. The web server farm is going to allow communication, or we are going to allow resources in the web server farm to communicate in the Fabric back each other, right? So let's say web server farm is blue, and let's change the Microsoft tenant to be green. So both networks quote networks, and this is what tenants is basically. You're building virtual networks on top of a physical fabric, right? So we have a Microsoft tenant. It's also going to be able to talk using the same fabric. However, blue and green will not talk each other unless you specify a contract and a contract interface to allow this to happen. If this is not in place, if you don't have a contract in place, this communication will not happen. They are only going to exchange resources in its own tenant. They're not going to be able, listen to me, they're not going to be able to talk between different tenants because we need to specify a contract to allow that. And a contract, if it makes it easier for you, is an access list. It's what it is. Obviously, there's more to it. You have way more features, way more options, but it's just an ACL. It is what it is. It's an ACL. It's a layer 3, layer 4 access control list, which you inside of it can specify the direction, two-way, bidirectional, or one-way, in which direction we're going to allow the traffic to go to. So let me continue. Application profile. This inside my network, we can create a particular section in which we are going to group resources based on application. So let's say this is application web app 1, right? We create an application profile, and then we create an endpoint group in which we are going to associate the servers that belong to the web app, right? But this is not complete until we give some addressing so it can communicate in the fabric. This is done with a bridge domain. A bridge domain allows communication for those endpoint groups in the application profile. So with the bridge domain, I can then assign IPv4 network along with its default gateway so those application servers can talk in the fabric. Who are they going to talk to? In this case, I am expressing the database servers are going to talk to the application servers. How that's going to happen from a network standpoint, we create a virtual routing forwarder, or VRF. We attach both bridge domains onto the same VRF. Once we do that, they should allow communication. However, it's not going to happen until you, and this is the bread and butter of ACI. Please pay attention to this. Communication will not happen until there is a contract attached to both endpoint groups that allows it. The contract will be one way, right? Or bidirectional, okay? And don't worry, I am going over everything there is to know about tenants, but we're going to discuss each individual section more in detail. I just want you to know how everything talks in ACI. We took out the VLANs, we took out, 802.1q. This is no longer, here. We don't focus on legacy networking. This is software-defined networking. This is the way that you create virtual networking and leverage one physical hardware to run multiple customers or multiple networks on top of it. It's just like a hypervisor. You have a physical server, you install ESXi, you install Hyper-V, and then you start deploying VM. The hypervisor is ACI. The VMs are the tenant. Got it? Very simple. This is basically how you isolate networks in ACI. How do you build tenancy? Very simple. Let's go ahead and jump on the fabric. And let's build this tenant. Let's build the web server farm tenant so you can understand how everything fits together. Okay, I am logged in into my ACI fabric. In this case, I am currently logged in into the APIC. We're going to click tenants, and let's build that first tenant. Add a tenant, web server tenant. And let's make it even simpler. Web SRV farm. This is my web server farm. VRF, remember, we need a VRF to allow endpoint groups to communicate. Web SRV farm VRF. And press submit. We just built our tenant. Okay, let's take a look at that. So when you first get into your tenant, you're going to see that we have the root menu or the root section, which is the tenant itself. Below it, we have the application profiles. This is where we create that application profile that I was showing you in that PowerPoint presentation. If you click the tenant, you can see the dashboard. You can see policies that are applied on a tenant level. There's certain levels that you apply policies. You apply it to the profile, you apply it to the group, you apply it to the tenant, etc. Let's go and create that application profile. We'll right-click, create application profile, web SRV app 1. And let's say we have an application called app 1, and we have a couple of web servers inside that app 1, and we're just going to classify them here. So we have app 1. Now I can either create the endpoint groups inside the same wizard, or I can create them after. What I'm going to do, I'm going to create one here, and then the other one, we're going to do it inside the tenant. In this case, let me go back and check what was the endpoint group name. Okay, so the endpoint group name is app SRVs. So the app servers are going to be classified in this endpoint group. And what was the other one? DB-SRV. So we got to make two endpoint groups, one app SRV and the other one DB SRV. And each one will have a subnet, 10.150.1, 10.170.1. Both of them with a default gateway of 1.254. Okay, so let's go ahead and do that. Okay, let me go here, app-SRVs. Bridge domain. Remember, we need to allow communication in that tenant. We need to assign addressing to the endpoints inside the endpoint group. So let's create a bridge domain, app-SRV-BD, because that's my bridge domain name. And we attach that to the VRF that we previously created during the application profile setup. Next, it's asking us, do you want to allow or assign layer 3 addressing? Yeah. Plus gateway, 10.150.1, and the gateway is 254/24. Okay, we have options, and I'm going to discuss this after. Basically, this is what we allow this gateway to talk in this particular bridge domain. If we allow it to only stay in the VRF, advertise it outside of ACI, or share between different VRF. So in this case, I'm just going to leave it as is. We'll press next, and you can set monitoring policies and all that. We'll discuss that in another section. Finish, update, and then it's asking us if we want to attach to a domain. We'll do that after, okay? We'll press submit. Now we have this application profile along with the EPG of app SRV. We just assign servers into this app SRV EPG, and they are going to be classified in the application profile web server app 1. Okay, let me go ahead and create another one. In this case is the DB SRVs. So this is the database servers endpoint group. We are going to make another bridge domain, DB SRV BD, bridge domain. VRF, attach it to the same web server farm VRF. Next, add the subnet, 10.170.1.254.24, that's my gateway. And we also leave it in private to VRF. We'll press next and finish. And if everything goes out well, we should have it here. There you go. Now we have both the app servers and the database servers. Simple. This is how you build a tenant. In the next video, we're going to go more in detail and how do we allow this communication to happen, and more information about the contracts and the networking itself. Okay, everyone, in our next video, we're going to take a look at application profiles and endpoint groups. Thank you for watching.